This is the last section. Study into counting systems, probability. Whatever job you take in business, understand the nomenclature and the process a little bit, and be inquisitive in everything you do. Learn to learn, and you will be successful. Probability distributions and expected value. So now we're talking about conditions that create individual sample spaces and their probability all equal to 1. So remember, all probability one when working with one set of data. So let's start here with expected value and expected value of a probability distribution. That means a layout, a diagram, if you will, as a type of average and depends on a random variable. And we've been talking about a random variable in 8.4 in the sense of it being the size of the grouping or the exact number that we wanted to find the probability for. So we've been looking at that. So what is a random variable? That means X. Variable that describes the quantity of each category, of a category. Okay, so in the set we have a multitude of items. Think of it as an M&M bag. In an M&M bag we have brown, blue, orange, red, green, and they're all mixed up in this bag. Well, that's one set, and there have quantities of them. And we're studying the probability distribution of each of those colors within the bag. So a random variable is a function that assigns a trial number to each outcome of the experiment. And the experiment being a desire to figure out possibilities. So it's done very well. And these are whole numbers. So we're talking about 0, 1, 2, 3, ... We're not talking fractions. We're not talking any of those other items. So let's begin with an example to explain this distribution first, and then go into expected value, which is the crux of what we're learning. So for an experiment described below, let X determine a random variable and use the knowledge of probability to prepare a probability distribution. All right, M&Ms. Think of the M&Ms. The sum that appears when two four-sided dice, tetrahedrons, with sides 4, 8, 12, and 16. Okay. So let's look at a table of what we have, and then we'll look at the probability. I'm so sorry, I got a little bit cough. So we're going to make a table first. To understand how it appears in the program. All right. It's not hard, but it'll help us to glean what we need to know. So we know that the dice, the two die, have a 4, an 8, a 12, and a 16. Okay, so if I add 4 and 4, I get 8. 4 and 8, I get 12. 4 and 12, I get 16. 4 and 16, I get 20. So then if I have 8 and 4, I get 12. 8 and 8, I get 16. 8 and 12, I get 20. And 8 and 16 is 24. We catch the pattern. We're adding 4 every time, primarily, aren't we? So this is going to be 16, and we're also developing a cascade. 12 and 8 is 20. 12 and 12 is 24. 12 and 16 is 28. 16 and 4 is 20. 16 and 8 is 24. 16 and 12 is 28. And 16 and 16 is 32. These are all the outcomes. And we notice we have how many? 4 times 4 is 16. All right. Well, we notice some things. We notice we have 2 12s, 3 16s, 4 20, 3 24s, 2 28s, and we have singulars in 8 and 32. All right. Well, we're going to need that information so that we can construct this probability table. So to get the probability, okay, remember, now we're going to construct probability. Talk about fractions here. All right. So we know it's 16, right? 1, 2, 3, 4 by 1, 2, 3, 4. All right. So that is P of an event is going to be the cardinality of the desired event over the cardinality of the sample space. So here we go. All right. So if I have 8 as an outcome, I only have 1 out of that 16. If I have 12, well, I've got 2 out of the 16, which gives me 1/8. On 16, I have 1, 2, 3 out of the 16. I don't think I can do anything with that. On 20, my largest, 1, 2, 3, 4, excuse me, 4 out of the 16, I have 1, 4. 24, I have 3. I'm so sorry. So sorry. I have 3. And then in 28, I have 2. Should be 3 out of 16, and I put 8. Sorry. Coughing got me, I guess. 32 is the 3 out of 16. All right. So we notice that if we add up all the numerators, 1, 3, 6, 10, 13, 15, 16, or 14. Yeah, I got it right. 3, 6, 10, 13, 15. Oh, and that should be a 1. 16. So I get 16 out of 16. So this is what you need to know for that first problem. Here's our next one. Three balls are drawn without replacement, that means one at a time, from a bag that contains 5 yellow and 6 orange. There's 11 in our sample space. All right. The number of orange balls is counted. The number of orange balls is counted. So what we're looking here are, because there are 3 balls, so our N is 3, and we need all our combinations and figuring out the probability. So we have our X variable on top, and then all of what we have in regards to the probability. And we're talking probability here. So, and here we want the P of X. All right. So we can have, out of the 3 balls, and we're talking about oranges, 0 orange balls, 1 orange, 2 orange, or 3 orange. Okay. Those are all the possibilities for this. So now we want to construct our probability against that X variable. And now we're talking about what we've done before, which is that success and failure. So if we want 0 of the oranges, then we're going to have 6 choose 0 times, and then we want the yellow, 5 choose 3, all divided by, and in this case we want the total, 11 choose 3 for the probability, because this one is not talking about individual percentages. We have to calculate those individual percentages. So now we're going to do the 1. So that would be 6 choose 1 times 5 choose, and in this case, if we got 1, then we have a 2. All right, all over that combination of 11 choose 3. Our 2, we'd have 6 choose 2 times 5 choose, let's see what we'd have here, 1. All over, because these had to add up to 3. I'm making sure I haven't made a mistake yet. 3. So now I'm going to do the last one. 6 choose 3 times 5 choose 0. All over 11 choose 3. All right. So let's do some math. And I'll pull out my calculator. And I'm going to have this whole thing entered, or I can possibly have it reduced. But I'm going to do the whole thing. So here we go. 6, math, P-R-O-B, number 3, and we're choosing 0. And I get a side arrow for times. And then I'm going to do 5, math, P-R-O-B, number 3, choose 3. Good, yes. I'm going to divide that whole thing by 11, math, P-R-O-B, number 3, 3. Oops. Look what I did. Side arrow. Oh no. Oh, 3. Divided by, I forgot that, 11, math, P-R-O-B, 3, 3. Now I've got it. So I'm going to get this fraction. Then I'm going to hit my math and frac. And I get 2/32. 2/32. All right. Now I taught you that key the last time. 33rds. 2/33. Sorry about that. So I'm going to do the next one. And I'm going to go a second entry to help my, oops, sorry. Do it twice. And, oh, I did it too much. It's okay. I'm going to do it anyway. 6, math, P-R-O-B, number 3, and I'm choosing 1, side arrow, times 5, math, P-R-O-B, I'm going to choose 3, and I'm going to do, I did 1, so that one's going to be a 2, side arrow, and division of 11, math, P-R-O-B, number 3, 3. And this time I entered without a fault, and I get that. And I'm going to do math, frac, and enter. One is 4/11. What's happening here? So I'm going to do the third one for number 2 for the independent variable. Second enter to get that one. And I'm going to come back over here on that 6 and put a 2. And change my combination for the second entry to a 1. And I'm dividing. Okay, so then I'm going to do math, frac, and enter. And this one is 5/11. Now I'm going to do this second enter. Second enter. I'm going to change this one. Now I have all 3 of the orange. And no yellow. Oh, I meant to put 0. There you are. And I get this number. And I do math frac. And I get 4/33. And here is what we need right there. Be given a prompt. All right. And we would put these answers under here. This is how you'll be prompted. And we have this one here. In this one, they talk about a histogram. So we are too. The histogram, a diagram, is a graph. And they are quantity derivative. And in our case, or percentage. So, and they relate to the x variable. Okay, so that x that we start like 0, 1, 2, 3, 1, 2, 3, 0, 1, 2, 3, 4, those are the x variables that they draw. And there is no space in between the bars. So in this one, we notice that they're using probability. Of the x values. And here are my x variable. Okay, in the graph. So now we're going to read, now that we understand what the histogram is. Okay. For the experiment described below, let x determine a random variable and draw a probability histogram for the following. Then shade the region that gives the indicated probability. 3 balls are drawn without replacement from a bag that contains 3 blue balls, 5 white balls. The number of white balls is counted. Shade P at the least one, at least one white ball. All right. So let's do our probability distribution and figure out the probability shaded of the probability at least one white ball. All right. Okay, so we understand immediately that we don't have, that this one is not shaded at least, because it has to be at least or greater. So it's not this one, and the one is white here. So we know it's not those two, it's between those two. So let's do our distribution table. All right, so our x variable, is 3 balls, and we're talking white. 0, 1, 2, or 3. All right, so I got that down there. And now, and that's how many white. So now we want our P of X. So to have 0, I would have in R 3 choose 0 times R 5 choose 3, right? Over, write that differently. That doesn't look clear to me for some reason. We want 3 choose, oh, that's because I have the wrong numbers. 5, because we're doing white. Sorry, 5 choose 0 times 3 choose 3 divided by 8 choose 3. And at 1, I'm going to have 5, choose 1, times, in this case, I'm going to have the 3, choose 2, over the 8, choose 3. Probability. Now we're doing the third one, and that's going to be for 2 white, 5, choose 2, times, I'm going to erase that 3, so it won't be close enough. And that would be 3, choose 1, all over 8, choose 3. And then I'm going to have my 3, and that would be 5, choose 3, times 3, choose 0, over 8, choose 3. Okay, now I need the probabilities. And notice they are rounded to the tenth. So let's see what we get here. I'll get my calculator out and push it on this side. Let me clear everything. And we'll enter 5, math, P-R-O-B, choose. That's number 3. And we're choosing none for starters. Side arrow, times. And this is 3, math, P-R-O-B, oops, number 3, choose 3, divided by, what did I forget? Yep, you got it, side arrow, divided by 8, math, P-R-O-B, choose 3, and enter. So we have, in percent, a very small amount, 0.02. Okay. All right, my pen is dead, so I'm going to have to stop the video right here, and I'll take up right here in just a moment. Thank you. I'm sorry. Okay, let's continue on. So as I was saying, this is 0.02. I'm going to do the next one, which is second entry, and I will go back over here, and I'm choosing 1 of the white. Now, I am choosing 2 of the color to make the 3. See if I've got that right. I didn't change it. Oh, that's crazy. I didn't type right. Oh, that's what happened. I did it again. 1, man, 2, 3, 2, and the rest is good. And I'm going to enter. And here I'm going to get point. I'm going to say almost a 0.3. Almost. I better do 2 decimals. That way I'll know where it is. I better do 2. 2.7. That's more better. Now I'm going to do second entry, and I'm going to change the 1 to a 2. That one. And then I have to change the other one to a 1. And enter. So when I do that, I get the value of have here 5, 3, 2, and 1. Sure, I haven't changed anything wrong. 0.53. Oh, 54. That's what it looks like. And then I'm going to have the last one, second entry, and I'm going to do 3. I'm going to do 0 there. I'm going to get 1, 7. I'm going to say 1, 8. All right. So if it's between these two, the 0 does not cut it here. This is wrong. So it's this guy right here. And all the shades are in the ones we needed. All right. Looks good. So now it wants, and that's it. That's what we have. So now our expected value is our next topic in our study. Expected value is what can be realized, and that's where that average comes in. The chances of our desired event and it panning out. In other words, we've done each of the criteria above, and if we were doing the expectation of it, we would have our independent variable times the probability. So that's what it would be. It would be the sum. So in this case, we are looking at a table that is already done. They've already calculated the distribution. So now they want the expected value. So the expected value is going to be that 9 times the probability of getting the 9 plus the 12, because it's all addition, times the probability of 24, plus 15 times the 41%, plus we're going to have, I'm at the 15, 18 times that probability, 1, 7, and of course the last one, which is 21 times the 0.07. So this is a matter of calculator. Again, understanding what expected value is for the entire topic. Yeah, like before we did the white ball, and the time before that we did children. Whatever the topic is, we're getting the whole estimated values. And these are averages, because anytime you have a percent, you're getting that average amount from the total. Here we go. 9 times the decimal 1 plus 12 times the decimal 2 plus 15 times the decimal 1 plus 18 times the decimal 17. plus 21 times the decimal 07. And I get 1455. Oh, and this is a Z. Sorry about that. Should be a Z. $14.55. All right. So now we have, again, that same presentation we have of the distribution in the form of a histogram. And we're told here, suppose we have 3 balls are drawn without replacement from a bag that contains 5 red balls and 6 white balls. Number of white balls is counted. So we're looking at the white balls. So we want to determine the histogram of the white balls. So, and we're talking 3. So we're going to do our random variable x and then our p of x, because the histogram is done in that context. We can have 0 white balls, 1 white ball, 2 white balls, or the 3. All right. So in this case, we have 6 choose 0 times 5 choose 3 over, and the total is 11 choose 3. That's our first one. Our second one is 6 choose 1 times 5 choose 2 over 11 choose 3. Our second one for 2 white balls is 6 choose 2 times 5 choose 1. All over 11 choose 3. And then here we have 6 choose 3 at last, and 3 choose 0. Sorry about that. Divided by 11 choose 3. All right, now I'm going to do the math on my screen. 6 math, PROB, number 3, choose 0, up arrow, side arrow, times, and this one is 5. 5 math, PROB, choose 3, side arrow, divided by 11 math, PROB, number 3, choose 3. That's what I did. Oh, I forgot the 3 there. Sorry. Okay, So I have, for the first one, 0.06. All right. So the next one, I'm going to make it a 1 of the white balls. I'm going to make it a 2, choosing from the 5. And this is a 5. And this is a 5. And I write so horrible. I'm looking at it myself and saying, well, what did I write? That's pretty bad. So I've got my 3, enter, and I get the decimal 36. Now I'm going to do the one for the 2. change my sequence here to a 2 and a 1. And I get the 0.45. And then I'm doing the last one with the 3, all the same color, going backwards to change it to a other one to a 0. And I get 0.12. All right. So now I have my distribution table. And my first one is less than 0 and bigger than 1/2. So it's not this one. That looks good. And okay, because this is 1, 2, 3, 4. It looks like 1. So this one does not look good. This one does not look good. It's got to be this one. So let's look at the 1. The 1 is 3, 6. 1, 2, 3, and about 6. And the last one, the next one is 4, 5. So this is 1, 2, 3, 4, and 5. Yes. So this one is the 1. And this was too big anyway. That is the 1. What is the expected value of the white ball in the sample? So this means we have expected value of x. We said variable x is going to be 0.06 plus 0.36 plus 0.4. Oh, wait, I don't even have my numbers attached. What's wrong with me? This is 0 times that, 1 times that, 2 times 0.45, and 3 times 0.12. Oh, sorry about that. And now we'll do the math on the calculator. We're going to have, that's 0. So I'm going to have the 1 times the 0.36 plus 2 times the 0.45 plus 3 times the 0.12. And our expected value is 162. Let's see if I got the math right. Oh, problem out. 1, 2. So that is correct. Right. I entered everything right. Good. From a group of 8 physicians and 7 surgeons, this is our total of our sample space, a delegation of 3 from the is selected. Find the expected number of physicians in the delegation. And so we're saying, and we're talking physicians only. So here we go with physicians. And we'll see what we get on physicians. So we're going to do our, let me get that, sorry, I needed to get it lower. Thank you. And space. So we're going to do our X variable for physicians. Zero physicians, 1 physician, physicians, and 3 physicians. All right. So, and we're talking physicians. All right. So, we're talking about our 8. Okay, here we go. All right. So, in our physicians, we're going to have 8 choose 0 times, and the other ones are 7 choose 3 over 11 choose 3 for our probability. For 1, I'm going to have 8 choose 1 times 7 choose 2 to get the 3 out of 11 choose 3. Or 2, I'm going to have 8 choose 2 times 7 choose 1 over 11 choose 3. For my 3, I'm going to have 8 choose 3 times 7 choose 0 over 11 choose 3. All right. So now I have all of my structure. I'm going to do the math. Now, here we go. I'm going to clear everything. I'm going to do the 8 math, PROB, number 3, and choose 0, side arrow, times, and then now I have 7 math, PROB, number 3, choose 3. That's what I have. Good. And that's what I have. Yes. Side arrow, because it's 0 and 3, divided by 11 math, PROB, choose 3, and 3. 0.21. All right. For our purpose, we're going to round to 2 decimals. And so I've got 0.21. And now I'm going to do this guy. 8. Oh, go back. I'm going to do second entry. And I don't have to type so much. I'm going to choose one of the physicians and 2 of the surgeons. All right, and hit enter. See what I did. I'm not supposed to get one. How did that happen? 8 choose 1 times 7 choose 3. Okay, divide. No, I got it all. Huh. I'm going to type it in. I did something that I don't see. 8 math, PROB, number 3, choose 1, side arrow, math. Oh, back. So here I go. Times. And then I'm going to have 7 math, PROB, number 3, and now I'm doing 2, side arrow, divided by 11 math, PROB, number 3, 3. Okay. If I did it that many times, it's got to be 1.02. Very good. Now I'm going to do second entry. Oh, it's right. It's parts of physicians. Yeah, maybe that's it. So I'm going to have 2, 1, and enter. second entry, go back, I finally have 3 and 0. So the expectations is the sum. All right. So let's do some math here. We're going to add them up. So I'm going to have 0 times 0.21 plus 1 times the 1.02 plus 2 times the 1.19 plus 3 times the 0.34. And our expectation is that. Kind of high. Let me look at that. That's kind of high. They're saying 4 physicians, 4.4 expected, when the most we can have is 3. So I've done something incorrect. 0, 7, 3, 11. Oh, that's it. It's 15. I'm saying that's kind of big. Oh my goodness. I said, wow, something is wrong here in River City. I apologize for that. I don't know why I put 11. I guess because I was used to the balls. I am so sorry, class. Here we go. Let's do it again. Not bad. It just didn't look right. The numbers were too big. All right. So we have 8 math ROB. That happens. 3. And I'm putting 0. Side arrow times 7 math PROB 3 and 3, side arrow divided by 15 ROB 3 and 3, and this one is there we go, 0.08. Now we're going to do the next one, second entry, and we are going to put a 1 and change the other one to a 2. Make sure that I've done the right thing there. Yep. Enter. M37. Now we're going to do this one, second entry, and I'm going to hurry so I don't take up too much more of your time. But you can see, just focus, or you'll do an Alma. Oh my stars. 0.43 makes much more sense. It's got to add up to 1 or close to it. And I haven't been doing that for you, but all the probabilities equal 1 or very close to it. So here we have a 3 and a 0. 1, 2. So I'm going to add these just to see how close I am. 0.8 plus 0.37 plus 0.43 plus 0.12, and I get 1. Oh, that's good. All right, so I got it. Much better. God, that looks strange. Okay, so we want the expected value of our independent variable x. So we have 0 times a 0.08 plus 1 times the 0.37 plus 2 times the 0.43 plus 3 times the 0.12. There you go. Kept on looking at it. I mean, just saying, what? Here we go. So I'm going to have 0 here. So I'm going to have the 0.37 plus 2 times the 0.43 plus 3 times the 0.12. Make sure I have points on that and not make a disaster. There you go, 159. And remember, if you get 160, you can, that's okay too. 1.60. So that's expected. Now we're at the last one. A committee of 3 is selected from a club made up of 14 juniors and 16 seniors. Right. Okay, so here we go. What do they want? What is the probability? No, the expected. What is the expected number of juniors in the committee? All right. So our total number is 20. Okay, so we're going to build a distributive. No, we're going to distribution table. Of juniors. Okay, so we have our x variable. And then we have our p of x. Okay, so we can have 0 juniors, and that would mean juniors are 14. 14, choose 0 times the other one, 16 seniors, choose 3. All over 20, choose 3. Now we have 1. So it's 14, choose 1 times 16, choose 2 over 20, choose 3. 2. 14, choose 2 times 16, choose 1 over 20, choose 3. 14, choose 3 times 16, choose 0. 20, choose 3. All right, now we need our calculator, and we'll do some little math. Here we go. Clear everything. 14 math. Oops. Math, PROB, number 3, and we're choosing 0. Side arrow, times 16 math, PROB, for 3, 3. Side arrow. And we're dividing by 20, math, P-R-O-B, number 3. And I'm doing 3. And enter, 0.49. We probably should do at least 3, but if you come off a little bit off on your homework, do 3 decimals on the probability and that'll solve it. Just making sure you don't get frustrated with using what I've said, but I'm pretty sure it's all good. So we're going to do a second entry, and we're going to make it a 1 and a 2. Making sure that I entered the 1 and the 2, and everything else is good. Very good. Hit enter. One of the 14 and 2 of the 16 divided by my calculator. Put by hand here, 14, math, P-R-O-B. I don't know if I don't know. So I'll just do it. I might have to go all the way to the end before I hit enter. I don't know. So I'm going to do it again. 16, math, P-R-O-B, number 3, and I'm doing a 2. Side arrow, divided by, and this is 20, math, P-R-O-B, number 3, and 3. Oh, mercy, nobody caught me. It's a 30. It's a 30. I'm going, something is wrong here. It won't show on the 0, but it'll show on the 1. And I'm going, oh no. What am I doing wrong? And I can't add. Well, that's your instructor's problem. Sorry. Okay, and that means that one's wrong too. All right, we're ready. We're ready. Here we go. Let me clear it. So I'm going to do a second entry, and I'm going to change some things. That's correct. I'm going to do the 0, 0. Three, and this is 30. Bam. This is, and we're going to do 3 decimals. 1, 3, 8. Okay. 1, 3, 8. I'm going to do second entry. And the 1 and the 2. Uh, 4, 1, 4. Yep. Second entry. We're doing a 2, 1, and an enter. Decimal 3, 5, 9. Now I'm going to do the last one. A 3. 3 and a 0. And this one is a 0.0. I think that's going to be a 0.9. Sure is. So if I add them up, I'm going to have 101. It's pretty good. All right. So now we want expected value. I'm going to have 0 times a 0.138 plus 1 times a 0.414 plus 2 times a 0.359 plus 3 times the 0.09. All right. So I'm not going to do the 0. So it's 0.414 plus 2 times 0.359 plus times the 0.09. Okay, so let me look if I entered everything correctly on the screen. 414, 2 times 0.359, and 3 times 0.09. Good deal. And hit enter, and I have 1.402, and that's approximately 1.40. All right. Whew. What an issue your instructor has with addition. I am sorry about that, but I've caught it, and it's good that it happens. You can see that paying attention is a keynote to finishing and doing this. It's small math, very small math. Concept is concrete. Have to keep up with which section you're using and what to do with it. Okay, now you really are ready for doing the homework.